it'll be a bit of a quick roller coaster ride, and please feel free to ask questions at the end in any dimensions you wish, be that from employment opportunities through to just understanding the scope of our work. TNC is a big organisation, but for this, and we work nationally on the country, of course, many Indigenous nations. And here where I'm based in Noosa, where I've been most intensely working, of course, is on the country of the Kabi Kabi Nation. And I constantly acknowledge their the TOs here, past, present and emerging, because I'm working on their lands and in their seas and in really strong and close partnership with them. And I really love and respect the relationship we have in the work we're doing. And we find that Indigenous peoples around Australia are really, really supportive of marine restoration work and get it much more readily in most instances than us other white fellows, I suppose. And so that's just such a wonderful dimension to our work. The Nature Conservancy, for those who are less familiar with us, we're not such a widely brand-known organisation in Australia, but we are the world's largest conservation organisation, which is big but quiet, I suppose. Perhaps noisier in the States, where the heart of the Nature Conservancy is. But the Australia chapter has only got 70 or 80 staff now. We're growing, of course, but we tend to do much more of our work through scientific collaboration, backroom negotiation and policy support, and tend to be a little less, I suppose, outward facing in our work. But I suppose it's part of our scientific driven nature. We tend to be a little bit more quiet in the way we go about things, and really stick our neck out and become more public as the issue or topic really requires. We have over 500 scientists on staff, and we have programs in 72 countries, and quite a decent asset base. Now, not all that flows to Australia, unfortunately, but it means that the Nature Conservancy has quite an extensive global network that that TNC Australia, who I work for, can call on for technical support or other forms of support, or even collaboration. So often we have technical teams from different parts of the world supporting, say, a project based in Australia. Or one of our partners may ask us for specialist information, and we can connect them up to either one of our chapters or with one of our partners in one of those many countries in which we work. And so I think that's one of the real strengths of the Nature Conservancy. And of course, one of the reasons I chose to come and work from is this sort of big organisation, long-term view, very connected and very good at connecting people and science together. I'm specifically here to talk about the Nature Conservancy's work in the field of marine ecological restoration, and in particular in the context of Reef Builder. TNC has been working in this field for over 30 years, particularly out of places like Chesapeake Bay in the States, which I expect many of you have heard of. But that program has grown into many, many countries now, and Australia has a pretty solid program of work, which I'll explain briefly, in the marine restoration space. And its cornerstone of that work is shellfish ecosystem restoration. We've recently expanded into other areas in partnership with our university and private sector colleagues, looking at Aclonia restoration, started to look at abalone, rock lobster, looking at various models of restoring reefs that don't totally rely on the public purse or private donors to fund. And this work in the future should offer and provide a lot more employment opportunities for postgraduates from universities, and a lot more opportunities for collaborations between Nature Conservancy, its projects, and the university sector. Of course, we also already enjoy a fantastic relationship with UQ and the science fraternity, and we always look to expand those opportunities for collaboration where we can. Most of the public, I suppose, when we look at reef building, they like to see the fish, and they like us to report on the performance, or what does marine restoration do for things like fisheries resources. And that's fair enough. People understand fish, but really at the heart of our sort of marine restoration work is objective really focuses on what's in the background, which is of course the invertebrate communities. So it's like saving the soil to grow the trees. We really, when we look at reef building, we really focus in on the invertebrate communities, the marine plant communities, and how they're developing, functioning, interacting with each other. And because they're the heart of the ecosystem functioning, which the vertebrate species rely, we focus our monitoring systems very solely into that space, and we support a lot of research into understanding the nature of these marine ecosystems, because that work often advises reef restoration practice on the ground. So we love supporting students. Why shellfish reefs, particularly over, say, seagrass as our cornerstone? Well, it just came out of the work, perhaps by one of our leads in the past, Dr. Chris Gillies, who decided to have a dive into the status of marine invertebrates in Australia, and working with Bose Hancock, our Tennessee chief scientist for marine restoration globally, really discovered, probably almost so in parallel with also some universities as well, the complete loss of so many of our marine biofouling ecosystems. And that led us on a long journey of working with our partners to build a baseline case to understand the real status of marine biofouling in Australia, and to look at what opportunities there are to do something about it. At the end of the day, we really came up with, as a cornerstone, 3 cornerstone species that we would focus on: Sophostria, the rock oyster group. Now, it's no longer one species. We know now there's a group of rock oysters that we're working with. The Austria flat oyster communities, and Mytilidae, the mussels and the Australian native mussel communities that have all been decimated in the past, and really could do with a helping hand to restore back as cornerstones of the functioning of healthy estuaries in this country. We know also that they are keystone species. They provide the reef structure, which forms the basis of the habitat or ecosystem type, which is basically oyster or mussel dominated a marine ecosystem type. So although a lot of focus is put very much into looking at the shellfish themselves, we're actually interested in the complexity of the ecosystem structure and function, how it also interacts with soft sediments, marine plants growing, for example, here on the right, in association with those harder shellfish reefs, and also therefore how the vertebrate communities, both aquatic and terrestrial, interact with those communities as well. There are many different types of shellfish reef ecosystems across their range around eastern, southern and Western Australia, and therefore there's no one-size-fits-all restoration approach for these communities. We know particularly with the rock oyster systems, they tend to be intertidal, but historically they did grow down to like 9 meters water depth subtidally. And I know from some grab samples we've done in the Noosa River that we do find rock oysters growing down at 4 or 5 meters as long as they can stay out of the sediment quite happily. But they don't naturally reform ecosystem structures and complex ecosystems in these environments anymore. In fact, what we know with the Angazi flat oysters and the rock oyster ecosystems, that we've lost over 95% of their area coverage across their range in Australia. And TNC has nominated them to be listed as a critically endangered ecosystem type under the Environmental Protection and Biodiversity Conservation Act, and they're currently being assessed. And we're pretty certain that we've got enough data to end up with that listing, probably by the end of next year. It's a very slow assessment process. So we're really looking at recovery of critically endangered marine ecosystems. And when we keep diving in and do more research and more collaborators, we all work, we understand just how expensive that loss has been. And therefore, what are we really looking at with our coastal estuaries, say in Queensland? Let's go be a bit parochial. Is that how can they be functioning at any really healthy level when numbers of hectares of this ecosystem type, which is a keystone ecosystem for the functioning estuaries, has been completely removed? So there's a bit of an elephant in the room here in terms of what state are our estuaries really in. Different types of oyster ecosystems, as I said, across their range. So we have to look at them differently when we go into different estuaries, and be careful not to generalize too much with our public communications around what we're talking about in a given place. They have commonality, the way the ecosystems function in the different estuaries, as many of us here in the room will know, but they are also different and are responding to their localities in different ways as well, which we have to be mindful of. Just a quick lesson for those who are less familiar with shellfish histories. What really happened is prior to 1790, virtually all Queensland's east coast estuaries had extensive oyster beds across them, like hectares of beds actually. And with the early settlers, white settlers, came a fairly extensive mining activities, as we know, for all sorts of reasons. We were mined directly for food, for the shell to be used in the kilns, like you see out at Santa Helena Island there, the limestone kilns for mortar, for brick and modern day building construction. I know the local Noosa Council is based on a massive oyster mill that used to be found up at our local Twanton Reef area. And with that, and with the changing and cleaning and modification of the estuary fringes, really in a fairly short period of time, we saw the real loss of wild harvest of oysters and oyster-related species in our coastal estuaries, and really a transformation into basically what was back then mostly stick and basic rack-style aquaculture development. So for all of us alive today have grown up in most of our estuaries, particularly along the east coast here, most oyster ecosystems we've seen are either groups of oysters growing on piers or jetties and pylons and so forth in sort of small isolated pockets, or we've seen extensive aquaculture leases and aquaculture production of oysters for human consumption. So it's interesting. So when we go to talk to the general community about oysters, the first association most people alive today have is oysters food, oysters food, oysters food, oysters food, because most people don't really have the association anymore with the oysters as being a more complicated dynamic player in our coastal estuary systems. And that's fair, because most people alive, unless they live in some areas, say like Port Stephens or south in the Hunter River, perhaps in the Richmond River and a few other places, who have seen oyster beds in their full functioning sort of glory, really have no real sort of life history association with this wild ecosystem type, making oyster ecosystem recovery as something to invest in as a community a very difficult sell for us. But that's where we come in, generation restoration. We're happy to be in, of course, the international decade of restoration. We have spent the last 8 years in Australia in the Nature Conservancy list working on shellfish restoration. We've all had a longer history and interest in different forms of marine restoration. There's been quite a lot of work going into understanding the nature of marine ecosystems and working out how we can do it. We've learned a few things along the way. One, it's quite complicated. Two, it's rather expensive. And three, the socio-political dynamics of getting a marine restoration project up and delivered successfully are horrendously complicated, difficult, and time-consuming. So when we approach any form of marine restoration, there's actually quite a lot of work to convince decision makers, but also the general public in the public spaces in which our marine restoration work takes place, to convince the people of why bother. And it's actually quite a lot of work to do. People like us who are trained in marine ecology, are trained in the sciences, we get these things rather quickly. But I can tell you from over 130 face-to-face meetings with locals just here in Noosa, the general public have got a lot of other interests, and they expect things like ecosystems to just go along and do their things in the background of their normal lives. And their sort of touch points are fairly light in terms of nature, their interactions with nature often, and what they expect from nature. So it's quite a job to convince them to A, to spend public money on this kind of work, but B, to take them on the journey of why we're going through these quite complicated processes in consultations to get marine restoration projects up and running. What that usually results in for us up until the present has been we get a lot of approvals for pilot scale projects. It's all good, yep, go and do it at small scale, a little bit here, a little bit there. Don't upset too many people, don't upset the apple cart too much. Do a little bit, do a little bit, do a little bit. So I've probably had a, as I said, about a 25-year history of doing pilot projects. But look, it's not good enough. And we all know that we need to get marine restoration, be it of shellfish reef ecosystems or be that of seagrass meadows or any other ecosystem that we like to talk about at scale so that we can demonstrate achievement of ecological performance at scale, be that local estuary scale or system scale across estuaries, across the range of a species or complex of species. So we're really at the start really of the real restoration journey. We've been doing restoration pilots, but now we have to get to scale to really start making a difference to the functionality of these estuaries. We therefore have to produce some really high quality and defendable stats about why invest in these projects and spend quite a bit of time at the front of our projects convincing people of the benefits and giving them also time to absorb, understand, and get with our restoration story. We're getting better and better at it. We also often, it's worth us investing in selling the other possible benefits and opportunities that marine restoration can bring. So me being parochial today and just focusing on, say, intertidal shellfish reef restoration, shoreline protection is a great story for us. If we can do shellfish restoration that not only works towards restoring a lost ecosystem type, but we can also talk about stabilizing riverbanks, dealing with wave attenuation, so reducing the energy out of waves so they stop eroding shorelines. This is really important in places where we have narrow rivers or narrow estuarine areas with a high boating traffic, or estuary areas that have very high fetch and modified shorelines that are now more vulnerable to erosion. Marine restoration can play a great role in supporting local government or state agencies with solving challenges like shoreline erosion. We can also increasingly sell the story that as we make marine restoration projects work beyond sort of research and pilot scale, as they get bigger, we can talk about job creation. We create jobs, we create work. We create work because we need scientists working on these restoration projects. We need different types of people, which I'll show you in a sec. And all that is income generation and job generation at a local and regional level. And that's a very, very useful and important sell with policymakers, but also particularly with funders. So as you can see, we make it very clear when we do this restoration project scale that there's a diversity of people who benefit economically from the work, but also get to be involved. So there's upskilling, not just upskilling, but collaboration. And of course, the university sector is actually experts at collaboration and partnerships. This is a no-brainer, but in this area of marine restoration, we have to pull in new partners and different partners. Aquaculturists have to work with us. Construction sector that actually has very little expertise in marine restoration is now slowly growing more expertise as they do more projects with restoration partners. Of course, scientists, fantastic, plenty of good scientists available to support this work. Aquaculture sector, as I mentioned, looking at collaborative ways we can work together, things that benefit the industry, but also enhance marine restoration. Quarries, we have to work with quarries, and we need them on site because it's a good deal on rock and other substrates we use to form the base of, say, shellfish reef restoration projects. And of course, the general public have to be on the journey or we just get kicked out of Rome. We are very vulnerable in the marine restoration community of being sidelined, downsized, or slowed down by even just a really small number of complaints from somebody local in the community. 1 or 2 complaints can completely derail a $1, $2, $3 million project. Funny that it is, and I think that's mostly because marine restoration is more widely known in science and conservation circles now, but with decision makers and local government, it's still a relatively new concept because they haven't worked with it very much. So their confidence with dealing with public feedback and often quite strange and curious public questions about the nature of the work, they're not used to it. So it's still a fledgling industry in that space. And so the sensitivities around this work is still quite high. And we have to pander to that And when we resource projects, we have to be mindful of it. Excuse me. Okay. Excuse me, I'll see if my voice holds. Excuse me. So one of the things we've done recently, of course, is we've got up the National Reef Builder program. 13 reefs across Australia. Sorry, just dealing with my post-COVID cough. Reef Builder is a $20 million federal grant to the Nature Conservancy to work with its partners at 13 shellfish restoration sites across Australia. It's a regional employment package and COVID-19 stimulus regional program as a stimulus package. So we're granted this money because we generate jobs and we generate connection and partnerships on a wide landscape across many different areas. That was the main reason we're given the money, not through some reason to need to restore a critically endangered ecosystem, because shellfish are not listed as critically endangered, but because we generate work and partnerships. Our first major project was in Port Phillip Bay and continues to work. Before Reef Builder funds turned up, and now we're in about year 7, year 5 of work in Port Phillip Bay to restore Angazi subtidal reefs and mussel beds, and that's in partnership with the state government. That work's been really going good, and it's really been our flagship project. It's worked large scale, many hectares of restoration, and many layers of project work going on, and always continuing to scale up. So the difference between, say, Queensland and Victoria at the moment is the Noosa Oyster ecosystem restoration project, excuse me, has taken about 5 years to get to the stage where it is now, whereas in Lakes Entrance, we started and finished a project in 9 months. And that's because the agencies in Victoria are on board with the restoration, they accept the restoration philosophy and approaches, and they've had time to get used to how it works. And so the permitting and the process of delivering the project has just become much, much more efficient. The other place like that is in South Australia, where the state government is also a really solid partner. And look at the size of these reefs. Windara Reef, 20 hectares, big footprints, really working at scale. Malta Reef patches over a fairly large restoration field of work. And now multiple sites. So in South Australia and Victoria, we also have a rolling program of shellfish restoration work, focusing in this instance here, of course, on the flat Angazi subtidal oysters, which honestly said, of course, are a little easier to work with in some ways because they're fully subtidal, out of the view of the public, tend to be below the level of boating traffic. And so less, I suppose, contentious than, say, working with rock oysters, which grow much more on the fringes and in intertidal and shallow subtidal areas. The reefs often start life in these subtidal reefs as a limestone base. They get very quickly covered in algae, which is a feature of all reefs in the modern estuary system. The high nutrient levels means there's a lot of algae around. And it's one of the things that prevents natural restoration and why augmented and assisted restoration is required. But we then reseed those reefs, we help them out, and they successfully can overcome some of those impediments. Adelaide Metro, you're using limestone. This is a freshly laid reef here. Reef base, that'll become quickly algae covered as well. But then the grazers will move in, and the Nature Conservancy and state government will reseed those reefs by pouring bags of Angazi reefs, Angazi oysters set onto oyster shell in amongst that rock, and that reef will take on. One of the things I want to show this GLENELG reef is what we often see with the Angazi reefs, but we're also seeing with the rock oyster reefs, is one of the responses of the recruiting wild oysters is that they recruit to the undersides of surfaces rather than to the top side. So anybody watching who's particularly interested in shellfish restoration, if you want to go and look at your oyster reefs, you'll see that a mature oyster reef will have rock oysters, and in this case Angoza oysters, growing on the top surfaces of rocks, competing with algae, competing with predators, and competing with sediment. But younger reefs, and often the younger growth, tends to settle on the surfaces where they can be washed free of sediment, and where algae, which requires, of course, photosynthesis, is less likely to grow, and therefore the oysters have a more competitive advantage. Very interesting fact. So when we put down reef bases, like for Noosa reefs, which I show you, there's a lot more undersurfaces for the oysters to settle onto. Okay, well, let me get even more parochial and talk about my pet at the moment, which has been, I suppose, really central to my life and my partner in crime, Megan Connell, who's not with us today. Our work has been a partnership with Noosa Shire Council to commence restoration of shellfish ecosystems in the Noosa river system. Very quickly, because I know I'm going to run out of time, and I always run out of time. I'll go back one, sure. I can go back one sec. So there we go. One of the key things we work with marine restoration is an international standard of work and internationally accredited processes of restoration. And this standard is really critical for convincing governments that we have a methodology that's transparent, defendable, and that they, if they adopt our project methodology, can also defend on our behalf. This has been at the core of our success, is having an independently accredited method of approaching restoration. And it has really helped the way we work. And with that methodology comes really intense investigation and science and background work before we even get on the ground and start the real fun work, which is putting rock in the water, actually the water goes in the water. A lot of planning documents, bathymetry, habitat assessments, consultations, lots and lots of work before we get on the water. Habitat and restoration modelling, which is a whole lecture in itself that we go through to decide where we work. And there's a really fascinating lecture just on that topic. And then, of course, in Queensland, only state in Australia which requires engineering involvement in the design of restoration substrates. So we've had to engage engineers to work with us, with ecologists, to design restoration substrates. For example, these are the reef patches looking in plan view in the Noosa River. So we go from, when we construct the reefs, we have to think of some practicalities. We can have our scientists mine on during the early stages, but then we have to work on and become practitioners, really on-ground practitioners. We need load-out facilities where we have the restoration bases, whatever they need. We need to deploy that. We have to have construction companies. We have to have hatcheries and seeding works and research involvement. And then, of course, we have to have pre- and post-construction monitoring, evaluation, and reporting. In Noosa, we decided on 4 different restoration sites. We established a Noosa loadout site by the side of the river, and we brought in rock from the quarry. This is local igneous rock, very large rock because of the high current flows in the river. And we brought in a barge and a specialist operator who loads that rock onto a barge and transports it out to those restoration sites. And this is equipment that's actually been specially designed by M&J Marine for rock oyster work. For example, this barge, it's made of aluminium, specially made for this kind of work, so it can get into the intertidal areas. The barge then turns up a place and carefully places the rock onto the restoration footprints. This is our Tewantin restoration site, just next to the Noosa Council chambers. And the rock is placed gently on the site into the specific shapes designed by the engineers and the ecologists. And it's fun work. It's intense, it's fun. The interesting thing to note that most people who think about how we work in marine restoration think of us like tree planters. small scale, grab a plant, take it out of a pot, put it in the ground, put some water around it, move on. Very lightly. They don't really think of us as being construction-based operations. But if we're going to work at scale marine restoration, particularly in this kind of project, we need to be able to work with big, heavy equipment. And a lot of our permit providers, be it a local government or so, are not used to ecology and construction going together. And it takes them a while to get their head around it. But eventually they do, and this is the Noosa Sound, they do let us go and do the construction work. But it can take a long time and a lot of negotiation. For example, for all these houses, we had to door knock every single house to make sure they're okay with the work. And just to finalise this presentation, you can see what we end up in Noosa. So there's some very, very rugose, large, chunky looking reef bases at our select sites, designed by the engineers to withstand the river flow environment in those particular areas. Here we go. You can see here's a bunch of reef patches being built in the Noosa Sound in the lower Wider Creek. And here's our barge here, building patch number 7. And here's a set of completed patches at the Noosa Sound West side. So they're set to be at mean high water, but they go down below the low tide mark because we know the oysters naturally go fully subtidally as well. We have to do construction monitoring in Queensland. It's expensive. We have to have engineers doing the monitoring independent of us and advising the construction supervisor. We have to do ecological monitoring as well. We have a lot of community engagement that needs to go on. If we don't engage the community, they don't accept our work. So we have them helping us collect shell washing and bagging. We have partnerships, of course, to collect broodstock adult oysters for our reseeding work. We have a hatchery work, which is currently going on right now as we speak, settling oysters onto the oyster shell on the left here, which is going to be sprinkled onto our reefs. We have community oyster gardening, where locals get to have some seeded oyster culch, oyster spats set onto oyster shell, put into baskets, and they get to grow them for us. And then we'll release them onto our reef foundations. And then, of course, we have really intense monitoring and evaluation, which is a great field of talk in universities going forward about collaborations. And of course, we have fish monitoring as well, which is not a core monitoring requirement for us. It's a very expensive requirement, very expensive activity, but it's what the public like to see. They want to see the public working on these reefs. And increasingly, we see that reef productivity and its role in helping restock fish to provide not beyond nursery areas, but also breeding areas for fish. The techniques are being worked on to develop ways we can tell that a lot earlier than we used to. So we always think after about year 5, you can start looking at the ecology of a reef and see that whether it's producing fish as opposed to aggregating fish. But Rod Connolly from Griffith University told me last week that he's come out with a technique which may be able to give us that information in 1 to 2 years. So the science is evolving to help us in this space. And we also have to do often other report on the side, work on the side. Here's a seagrass report we did on the status and trajectory of seagrass health in the Noosa River for the council as a sort of almost a sideline to our work there. And we discovered an 83% decline in seagrass in the Noosa River with no long-term sign of recovery. So this has been a big wake-up call for the council. And now they're trying to work out what the hell to do about it. Sediment is always a big threat to our rivers, estuary systems and to marine ecosystem restoration. So we're sponsoring a local sediment study in the Noosa River as well. And of course, we have really strong connection, as I said earlier, to the Kabi Kabi Nation. And here's Uncle Fred Palin launching our project and naming the reefs at the end of the project as well, which has a lot of really strong local resonance. But also, as you move into places like marine parks and work in even more regulated spaces, you know, the connection with Indigenous people, Indigenous owners is going to be really important. And having them working with us so closely that they were prepared to name the reefs and so forth for us is a fantastic outcome for our work. I thank many people for the slides in this presentation, and I thank you for your patience for letting me run over time. And I'm really happy to take any questions that we have time for. Thank you.